the marginal rate of substitution. So what the intertemporal elasticity of substitution tells you is how does Cs plus 1 over Cs react to when the marginal rate of substitution grows. Now, for UCS being equal to Cs to the power of 1 minus sigma over 1 divided by 1 minus sigma, what is the marginal rate of substitution? It is U prime Cs over beta U prime Cs plus 1. As we've shown half an hour ago, right? Actually, this is the general definition of the marginal rate of substitution. This is the function form. And so if we put things together, we get the marginal rate of substitution is equal to Cs to the power of minus sigma divided by beta Cs plus 1 to the power of minus sigma, which is 1 over beta Cs plus 1 over Cs to the power of sigma. So that's the marginal rate of substitution for this particular utility function. All right. Now, let's take logs on both sides with the log of the marginal rate of substitution. Now we have the log of 1 over beta plus sigma, which is the log of sigma log of Cs plus 1 over Cs. Now let's multiply both sides by sigma, and you get sigma times log marginal rate of substitution minus sigma log 1 over beta equals the log of Cs plus 1 over Cs. And now let's take d ln Cs plus 1 over Cs, oops, that was too early, over d log MRS, and that gives you sigma. Oops, nope, I made a mistake. Should have been, sorry about that. I knew there was something wrong. I hate erasing stuff that I wrote in the whiteboard, but that's. Now, let's make a long story short. For this utility function, the intertemporal elasticity of substitution is 1 over sigma. Now, for this utility function, the coefficient of relative risk aversion is sigma. What does that mean? It suggests that if you take this utility function, you have and sigma is very high, then you have a person who is very risk averse and a person who has a very low intertemporal elasticity of substitution, because 1 over sigma at that case is very low. So if you use this utility function, the attitude towards risk and the attitude towards fluctuations in consumption are closely related. Highly risk-averse people also hate fluctuations in consumption. Now, there's people who say this is cool, and there's people who say, oh, this is problematic, because the attitude towards risk is one thing, the attitude towards consumption fluctuations is another thing. They're somehow related, and so there's preferences that try to disentangle the two aspects of behavior, right? So-called Epstein-Zinn preferences. But I was glad that you brought this up, because if you had a model about uncertainty with portfolio choice, we would use the same utility function, and we would see that sigma is also very important as a measure of relative risk aversion. Here, we know that if sigma is high, then the intertemporal elasticity of substitution is very low, and if sigma is low, then the I is very high. Now, do you know what happens if sigma is equal to 1? So what happens to this thing if sigma equals 1? Problem, right? Because if you said you take cs to the power of 1 minus sigma, you set sigma equal to 1, you get 1 minus 1, you have a 0. And if you take sigma equal to 1, you get a 0 as well, if you're dividing 0 by 0. There's a way to handle that. And in fact, is the log function. Right. So the log function, if you take log utility, it's just a special case of this more general form, and you just set the intertemporal elasticity of substitution equal to 1. This is called, goes back to a person called L'Hopital rule. Right? You don't have to know that rule. If you know it, then it's good. In my book, I have an appendix where I derive that. It's actually easier than you think, but it's not obvious, and sometimes people use the log function to specify preferences, and then it's good to know that the log function is just a special form of constant intertemporal elasticity of substitution with sigma equal to 1. We'll come back to that because sigma is super important in those macro models. Why is sigma so important? Because sigma, why should we be interested in this stuff? Well, because recall optimal consumption requires that the marginal rate of substitution equals 1 plus r. Bingo. So this is not, this is not how, who has heard about the marginal rate of substitution? Economists, but no one else. But now, if we replace MRS by the interest rate, then this tells us how this ratio reacts to changes in the interest rate. And this is important. Because this this is important for macroeconomic behavior. So 2 or 3 more slides, and then we'll be done. First thing is there is a meta study by a bunch of Czech people, one of them being called Havranek. And they computed, estimates of elasticities of substitution. And it turns out that the Germans have a very low intertemporal elasticity of substitution, and the Japanese have a very high one. By and large, rich countries have higher elasticities of substitution than poor countries. So Thailand has a low one, Brazil has a low one. Which makes intuitive sense because, we're talking about reducing consumption in one period and increasing it in other periods. Now, if you're consuming very little, then this is very hard. So if you have a banana a day, then giving up that banana is painful. If you have 1,000 bananas a day, then, reducing consumption by 1 banana doesn't hurt very much. Germany is an interesting thing, right? That falls out. Germany is a rich country, and still people are very reluctant to trade off consumption across time periods. It's an interesting study. So, great. So we have 5 minutes to go for the break, and we're exactly where I wanted us to be. Because let me take stock. So where do we stand? We recall that the current account balance is the difference between the net international investment position at the beginning of period 1, t plus 1, and at the beginning of period t. if we forget about valuation effects and the capital account. It equals the difference between savings and investment. So far, so good. So far, we didn't have any investment, so basically the current account was just reflecting savings. Saving decision is the mirror of the consumption decision. That is the choice of the optimal consumption path. And the optimal consumption path is depending on preferences, the real interest rate, preferences as reflected by beta and sigma, the real interest rate, and anticipated future time path of exogenous variables, for example, output. Now, let's do an example. Here are the assumptions. Now, we do a little model simulation. And the good news is you will do this today after the lunch break. But let me tell you what I'm giving you as a. So we assume that 1 plus r beta equals 1. What does that imply? Well, flat consumption, right? So that the consumption path is the same. That we assume that at the beginning of when we let the model run, the NIP is equal to 0. Okay? We assume that there is no government spending, so forget about it. Right? GS equals 0. Now we assume that there's a temporary drop in output. So ys is y, which is a constant, minus delta s. Delta s is delta in period t, and delta s plus 1 is rho times delta s for s greater or equal to t. With rho, this guy is called rho, another one of these Greek letters, being bigger, being 0 and 1, could be 0, could be 1. And in fact, the value of rho will be very important. Now, what I want you to show is, oh, actually, no, that's not what you have to. Well, I'm going to show you to start with after the lunch break, and then I'll let you do the rest. This is the time path of output. And the time path of output is that in period t, output drops by 50 units, from 100 to 50, and rho is 0.6. So output returns to the long run steady state after a while, right? So this is the typical case of a temporary output shock, a negative one. Now what I want you to show is that consumption takes this value, that the current count takes this value, and that the time path of consumption, the current account, and the net international investment position look like this. Now, you may be scared. Don't be. I'll give you some instructions, and then I'll be here, and I'll give you 90 minutes to do this, and then we'll discuss the solution. And ideally, there's someone coming to the whiteboard and cranking it out. Right? So that's and don't, right? It's not that I'm grading you right now, and it's no. We've done a lot of stuff this morning, and we are ready to go into this now. And it's very informative, right? I'll talk about the interpretation of this as well, not just the math. And it teaches you a lot about the model that I've been introducing this morning. Okay, so I'll be back at 1. You'll be back at 1, hopefully. At 1, I'll explain you the problem set, right? It's problem set 2. Then I sit here, and I give you time to think about it and to discuss the problem set, and then ideally, then we'll have a break. And after the break, ideally, someone comes to the whiteboard and shows how to get to this solution. But first, get some food to refuel, right? Okay, see you then. Oh, that I'll
The keyword is.
I'll give you some hints, right? It's I will not give you the solution because that wouldn't be fun, but I'll give you some hints, and then you'll see it's doable, right? It's not, and I'll get rid of this because otherwise I'll take this.